Hello and welcome to Microsoft Virtual Academy. My name is Chris Randall. I'm here with Carl Robler, and we're here today to talk about SQL databases to Azure. Let's get started. Carl, tell us a little bit about yourself, if you would.
I'm the current content lead for SQL database content at Microsoft. I've been working with SQL Server since version 6.5. I've authored a number of books, starting with SQL 7. I've written a whole bunch of white papers for SQL CAT, which is a customer advisory team, and spoken at numerous SQL Past conferences and SQL Saturdays.
And significant to today, a quick word about me. My name is Chris Randall, and I'm a senior content developer with Microsoft. I am focused on data platform and analysis training. I create courses for database professionals, for BI developers and analysts, and I think our vintage with SQL Server goes back about to the same point, back to the mid-90s. So we're going to talk a little bit about SQL Server in Microsoft Azure and where the different places are that we can find it. We're going to talk about getting started with SQL Server in an Azure virtual machine as one place to find SQL Server. We'll then talk about getting started with Azure SQL Database, which is another place to find SQL. And then we'll cut into actually doing the migrations, doing the lift and shift of your on-premise SQL Server data into the cloud. We'll finish up with a short section on security and on data resiliency and what's available to us in the two platforms. Let's get started.
Sounds good.
All right. In our first module, we're going to talk about, in general, how SQL Server exists in the Microsoft Azure ecosystem. And we're going to talk primarily about SQL Server in Azure virtual machines, or VMs. And then we'll talk about SQL Database as well. And then we'll drill into each of those in separate modules. So, Carl, let's talk about what we're calling here the SQL Server Cloud Continuum. The target audience for this material is experienced SQL Server professionals who are working in an on-premise environment, right?
Correct.
And they're looking for ways to move to the cloud.
Correct.
So where are they in this, and where are they going?
Well, historically, the DBA is running in a SQL Server in a physical machine, and over the last half a dozen years or so, a lot of the on-premise environments are actually moving to virtualization on-premise. As the clouds come into play, those virtual machines on premises can be seen as you're just changing the infrastructure to being an on-premise data center to being a Microsoft infrastructure where you're running a VM and basically in Hyper-V in the infrastructure. You're still managing the virtual machines, but you're not managing the infrastructure. That's moved out of your data center. And the next step up is to move away from actually managing the infrastructure and just manage the database itself and let Microsoft manage the entire infrastructure for you, which is Azure SQL Database, which supports various kinds of software as a services development solutions in Azure.
So if I'm an experienced SQL DBA, whether I'm managing SQL servers in a physical machine that I have access to, or in a virtual machine that's hosted in Hyper-V, for example, we're talking about simply lifting that up into, not simply perhaps, but moving that up into hosting in the cloud instead of hosting on-premise in that first pass, moving from physical to infrastructure as a service, right? IaaS, which always takes me too long to say. Mm-hmm. And then potentially, and we'll talk about some use cases for this, potentially moving completely to a virtualized database instead of a virtualized physical machine, right?
Correct, and really the difference here is really how much you want to manage yourself versus let Microsoft manage it for you and really focus just on a database.
Sure. Well, let's compare these. Which do I use? If I know that that I can run SQL Server in an Azure VM, or I can run Azure SQL Database, what direction am I going to go? How do I choose?
The first place to go is to sort of figure out what you're trying to do. If you have an existing SQL Server 2005, 2008, 2008 R2, et cetera, solution that has to run in that version, it's going to dictate you have to run a VM, because Azure SQL Database, you don't control the version. You basically have a version that's similar to SQL 14/SQL 16, right. 2016, and that's the version you run in. You do have some backward compatibility options that can control that somewhat. The next step is, do you need instance level features? Do you need SQL agent jobs? Do you need linked servers? Do you need DTC? These things are not available in Azure Database. There are alternatives to them, but if you need a one-for-one migration, you're going to have to go to an Azure VM. The other key differentiator is how much do you want to manage yourself? Do you want to get out of the management of all of the infrastructure, all of the physical components, the network switches, the hard drives, et cetera? If you want to get out of that, but still manage them yourself, but out of your data center, you're going to go to VM. If you want to get out of that completely and let Microsoft manage that entire infrastructure, you're going to go to Azure VM. And so the other key thing is so if you're taking an existing app, you're likely to migrate the existing app to a VM because it's a lift and shift. You don't have to change that much.
But there's less work.
There's less work to migrate it. Right. If you're building a new app from scratch, most users I've run into, most customers, are going to evaluate going straight to Azure SQL Database to get right. out of that management and just focus as a SQL DBA. I want to focus just on my database. And they evaluate, can I do it in SQL Database? And many users are actually combining both. They'll do some things in VM and a lot of things in SQL Database, and they'll use both together.
Sure. Makes sense. So what have we learned in this module? In addition to on-premises, SQL Server is available in 2 cloud environments, in an Azure SQL Virtual Machine and in SQL Azure Database. We also learned that if we want to maintain control over the operating system and the SQL Server instance, we should use SQL Server in a VM. But that does mean that we have the responsibility for all of the related tasks. We might also use SQL Server in a VM if we need to match an existing requirement for an application, such as a particular version of the operating system or version of SQL Server. For new applications, or to get out of the business of having to manage the infrastructure, we heard that we might want to use SQL Database. All right, welcome back to our MBA course on migrating SQL databases to Azure. We are now ready to begin our module on actually performing the migration. We're going to take a look at performing the migration to SQL Server in a VM, and then we'll talk about some of the things we can do to migrate to SQL Database. You ready, Carl?
Ready.
All right, so let's start with migrating to SQL Server in a VM. There's a bunch of different ways I can do this, and we've already talked about the fact that at the receiving end in the VM, it's still just SQL Server, so there should be some familiar things here.
Yeah, so you sort of have 2 methods to migrate. They all are essentially the same as going SQL to SQL on-premise. You can just do a backup and restore, backup from your on-premise database and restore to your VM in the cloud, with some various mechanisms for getting that backup to the cloud, but it's just restoring a backup. That has some amount of downtime because you're offline while you're restoring. You don't want new transactions in your on-premise system before you get it into the cloud. If you want to reduce that downtime, you can use either transactional replication. If you're already using it, you just configure your Azure VM as a subscriber and let them sync up. And once they're synced up, at some point in time, you can just cut over. And you also have always on availability groups, which is the same thing. You configure the VM as a replica and let it catch up, which essentially does transaction-based replication to the cloud and keeps it current. And at some point, you can switch over and make your replica your primary.
So it sounds like that with the additional info about restoring to blob storage to get started, it's really like going from virtual machine to virtual machine on-prem. I mean,
it's exactly like going virtual machine to virtual machine on-prem, or from data center 1 to data center 2, or it's just a backup to a backup to a restore. Sounds
pretty comfortable from an experienced VBA.
For DBA, is something you're familiar with. The only difference is how you get it into the VM.
Right, and you talk about that in the book in more depth.
Yes. All right. And we'll go through it in the walkthrough, actually, too.
Okay. I think I caught myself saying VBA. I had a weird flashback just then instead of VBA, but let's not go there. All right, so now if I want to migrate to SQL Database instead of SQL Server in a VM, it seems like there's a whole bunch of different ways to do this. Hopefully you can steer us into what are some of the preferred ways to do it. Let's talk tools first.
So when you're doing SQL Database migration, the tools basically are you have to migrate the schema and the data into SQL Database. You don't use a SQL backup. And you can either do it through the portal, you can do it with Management Studio, you have a Codeplex tool called the Azure Migration Wizard, or data tools in Visual Studio, which will only migrate the schema, but also use to verify compatibility. And there's a new tool coming around, it should be out in the next month and a half, called DTA, or data, I'm blank on it right now.
So there's a new migration tool that's coming out we should watch for. Okay.
Yep.
And we can add that as a link to this course once it ships.
Yes.
We can go back and change
Absolutely.
it. So you mentioned that you can't do a backup. So help me understand something. When we were looking at creating a database in the portal, one of the choices was, in addition to blank database, there was sample database, and it also said backup. So I can't use one of my on-prem backups there?
No.
Okay.
The backup using the portal is actually a backup from another SQL database that's already in the cloud. So if you'll make a copy of your database and use that as a starting point for any variety of reasons, that's what that backup is. It's a backup from an existing SQL database in the cloud. For various security reasons, you're not allowed to take a backup from on-prem and restore it to a SQL database. You need to basically extract the schema and the data and move those into the cloud in some fashion.
So that's where these tools come in.
That's where the tools come in, both to move them and the tools come in to validate you're actually compatible.
Okay. All right. So let's break that out a little bit. We were talking before we started this recording session, and I'd created a slide with these 3 methods, and you said, "But wait, there's more. There's going to be another method." So let's talk a little bit about that here. So what I've got experience in is using SSMS, right? I'm creating one of those backpack files, right? I'm extracting the schema and the data. I do that from SSMS on premise, and then I upload that backpack file into my Azure storage.
Yes.
And then I can create a database from that.
Yes. The first step is you have to be able to create a backpack file.
Right.
When you go to create a backpack file, if your database is not compatible with SQL database, it will fail. And it will fail giving you information about why it failed.
So that's the compatibility check you mentioned.
That's that compatibility check. Very important when you're running a compatibility check with any of these tools is make sure you have the newest version of the, depending how you're doing it, with either SQL Server data tools or SQL Server Management Studio, because anytime you're working with Azure, you need to make sure you have the newest version of the tools because the compatibility checks will be out of date.
Right.
So you want to use those. And so you need to have a valid backpack. If you don't, you need to fix them. That's part of where we're going with the new tool coming out, which is, I said DTA, it's DMA. It's Data Migration Assistance. That's going to, over time, keep improving to, within the tool, actually fix compatibility problems on the fly instead of all the tools shown in the slide here. You have to, once you verify, you determine that it's not compatible, you have to step out of the tool and go fix it, and then come back into the tool to migrate it. Once you have a valid backpack file, which really is just a zip file that has the schema and the data in the file, you can then import that into SQL database using a number of methods, the portal, management tools, or PowerShell.
Now, if I've got a very large source database, potentially that backpack file could get rather big. Is there a way to create that backpack file with just the schema?
You can create a backpack file with just a schema. The typical way to create a backpack file with schema is to import it into a Visual Studio project using SQL Server data tools for Visual Studio, which basically extracts the schema, and then when you basically point that schema to an Azure V12 server, it will say, oh, you're compatible, you're not compatible.
Right.
And if you are compatible, you could at that point just migrate the schema, or you can, if you have problems with the schema, common one is you're referring to some role that exists, like a role that exists at the server level, but not at the database level.
Sure.
And so you just remove that, and then you can basically point that project back to your on-premise and basically removing that, or do it manually in Management Studio, and then you can create the backpack and deploy it.
Gotcha. So that's that method. That's that third method on our slide of using Visual Studio for that particular piece.
Yes.
Okay. All right. So you mentioned the fourth. Is that DMA?
The fourth is DMA, which is Data Migration Assistant, which is going to take the best of all 3 of these and be upgraded on a monthly basis. Again, we're cloud first, rapid deployment, rapid change is continue adding these capabilities into the tool to not only migrate from SQL to SQL on-prem to SQL Cloud, but also bring in capabilities to go from Oracle, from Access, from Sybase, from DB2, and bring those all into a single tool, so you can migrate, fix compatibility issues, and deploy to SQL DB all in one tool.
And while we don't have any particular discussion about some of those other source databases in this course, you've got some in the book.
I got some in the book, and again, this is coming out in the next month or so.
All right, so we'll update the MVA content to include a link to where you can download that DMA. I do know that I can get monthly updates of SQL Server Management Studio. Are the Visual Studio data tools, are they also on that kind of cadence?
Yes, both Management Studio and data tools are on a monthly cadence.
Okay.
And they'll actually prompt you when you're using them to say the new version available, or you can go up to the menu item and say check for updates.
Right.
But it's very important anytime you're working with anything involving Azure that you use the newest version of the tools. All the content on both MSDN and Azure.com assume you're using the newest tools. If something says it works and you have an error, first thing to check is, do I have an outdated tool, or am I using 2014 tools?
Right.
They won't work.
And that should extend to other tools like Azure PowerShell, for example.
Yes.
Make sure we've got the latest and greatest there as
Always
well.
get the latest and greatest. Yep. We're on a continual release cadence, and use the newest tools.
Okay. All right, so that we've left at this at kind of a high level. Here are a couple of different methods, and we know there's another method coming. If you want to get deeper into that beyond Carl's book, you may also want to take a look at something called the Azure SQL Database Migration Cookbook. We've got a link to this on the slide here. That'll walk you through a number of different approaches in some depth, and I highly recommend you take a look at it. All right, so as we've done in previous modules, we try to distill this to the key steps that we want to make sure we're paying attention to, even though we know there's every one of these has an asterisk at the end of it.
Yes,
right? There's always going to be special cases. But so let's do this again. Let's walk through what the key steps are going to be for migrating a database. And bear in mind, we're talking about both migrating to a VM and migrating to SQL database here.
So the first step is determine if you have compatibility issues or not. So if you're going from on-prem to a VM, your compatibility issues will consist of, you might be upgrading to a newer version of SQL Server, and there's maybe deprecated items, change of how things perform. So you need to look at those. So you go to MSDN and see what the breaking changes are, right. What's deprecated. If you're going to Azure Azure SQL Database, you do need to test for compatibility normally you're going to use Visual Studio data tools to determine compatibility. And once you figured out if you have compatibility issues, you're ready to determine how you're going to migrate. Your migration method will determine how much downtime you have, and basically you have to get your data from on-prem to the cloud. And when you're going from on-prem to the cloud, you're either using a backup or some method that reduces your downtime. Transactional replication works with both variations. Mm-hmm. Always on only works with a VM. And so you pick your migration method. And once you've done that, you actually migrate the user database. And again, the key point here is you're migrating the user database. You're not migrating the master database. You're not migrating MSDB. You're not migrating other databases. So to the extent you have out-of-database issues, logins, jobs, you have to recreate those in various fashions. And then test your application once you finish migrating it to see, does it work and how does it perform? And there's a lot of things you can do to handle both of those issues once you get it up there.
And that's one of the nice features of the Azure ecosystem is once it's up there, if we want to bump the performance, we can do that under the VM hood, or we can do that in SQL Database, right?
Yes.
We can go to another service tier. We can increase the DTUs.
DTUs if it's on SQL Database, or you can increase the storage, increase the CPU power if you're in the VM.
All right, sounds good. Hi, welcome back. This module, we're going to talk about authentication, authorization, and data resiliency. So we want to talk about security.
Absolutely.
We want to talk about protecting your data.
Yep.
Let's dive in.
Sounds good.
Let's start with security. So if I'm an experienced SQL DBA, I'm all about security. Mm-hmm. Right? I know about on-premise or locally virtualized SQL Server instances and that sort of defense in depth approach. Mm-hmm. Right? How does that translate to the cloud?
It translates in similar fashions. You have a firewall that prevents users from connecting, first of all. So they have to get through the firewall. You have to open the firewall. You can open the firewall via port number. You can open the firewall in SQL database based on the IP address or the IP range of your users. That lets them actually get at the database to see if they have authentication. They need to be authenticated either using SQL authentication or Windows authentication, and or shall I say, Active Directory authentication. And then once they're authenticated, we see what permissions they have. And they can have permissions through a master database, or they can have permissions at the database level itself. And in the contained user scenario, they only have permission at the database level. And then the final piece of this is you want to ensure all your connections are encrypted. That is required, and that is the default by SQL database. It will only accept encrypted connections, and in a VM, you can configure your server to only accept encrypted connections, and that is a best practice.
All right, so at the database level, or the database server level, we are securing things by firewalls, through users and permissions, connection strings, encryptions, what you were just talking about, and we're used to that. What's interesting is that in SQL database, there's a bunch of new features that are also then turning up in SQL Server 2016.
Yes, cloud
as far as, right, we go cloud first, right? So there are some interesting new things with encryption, with dynamic data masking, with row-level security, and automatic threat detection and auditing. And to promote a different course here on MVA, I've just recently finished creating a course on Azure SQL Database security that will cover those particular features, even though we don't get into any depth here. So let's drill into this a little bit more. Something that sometimes confuses customers is the difference between a server firewall and a database firewall in SQL Database. So can you talk to that?
Yeah, so basically for an administrator, to start with, when you connect to SQL Server, you need to have a server-level firewall that lets you connect to the master database. And if you have a server-level firewall open, you can then connect to all the databases that are associated with that server through that master database. And as an administrator, you want to have the server-level firewall because you're going to be administering, in many cases, many databases as a group. And you can do this through the portal or through the APIs. If you're configuring user access to a database that may move between servers because of a variety of reasons, for performance, for geo-replication, you want to have your firewall at the database level only, so that when a database moves from server 1 to server 2, you don't have the users not being able to access it because there's no firewall open. So that you do through T-SQL or through PowerShell is you create a database level firewall. So to summarize again, if you're creating a firewall in the portal, you can only create at the server level. If you want to have it just for the user for a database that's going to move between servers and geo-replication or other scenarios, you create it at the database level itself. And
interesting, you had said that if we didn't create it at the database level and the database moves to a different logical server, users aren't going to be able to connect because it's closed by default. Right?
It's closed by default. They would be able to connect if you had a server level firewall open on that other server, which you might not have for this user or this IP range. But just because they had permissions on the database level, when it moves to a new server, they don't have permissions.
So let's walk through this connectivity flow. So if I've got a server level firewall rule and a user needs to connect, if their IP address is in the range, they go, right? They can get into any of the databases on that server.
They can get to the database to see if they can connect. The firewall's open. They still have to have permission.
Right.
They need to go. First, you get through the firewall, then you get authenticated, and then you have permissions.
So before we get to the authentication and permissions, let's just make sure we're clear on what's going on with the firewalls here. But that firewall is definitely the first stop in that defense in depth.
First stop. Right. You start the server level firewall, and if you have an IP, if your IP address is in range, you can then go to authentication.
Sure.
If it's not the server level, then you need a database level firewall.
Okay. So if I've got, as we have illustrated here, if I've got 4 databases, and I've got special needs for that 4th database. I've got users who can get at 1, 2, and 3, but I don't want them to get to 4. And similarly, I've got a different bunch of users who want to get to 4, but not 1, 2, and 3. Can I do that? Can I set that up?
Absolutely. You do a combination of opening up server level firewall rules and database level. If the user's IP address has a rule at the server level, then they can get access to all 4 databases from the point of authentication, but they still can't get access to the database.
Right.
As an administrator, I'm going to want to be able to easily access all 4 of them.
Yep.
What you generally do is, for users, you're going to create database level firewalls, and for administrators, you're going to create server level firewall rules. The exception being, if you have an application that uses many databases, then it's going to be easier to create both logins and firewall roles at the server level because you have many databases and you got to maintain them in many places.
So it's as if I'm treating the multiple databases as a group of databases from that perspective. Okay.
Correct.
Makes sense. All right, so once we get through the firewall, assuming we can. Oops, I'm sorry, I've lost my place here. We didn't talk about actually how to configure the firewall. We just talked about its presence. So let's talk for a moment about that. I've done that in the portal, and you mentioned being able to do that in T-SQL as well, or PowerShell. What's
the server level firewall rule? You create that in the portal,
okay,
or with PowerShell, and you have to be on the server blade, not on the database blade.
Okay, that's why I couldn't find it once when I was looking in the wrong blade.
Yes,
okay.
And it's very easy to get confused between the server blade and the database blade. Yep. You can get to the server blade from the database blade, or you can get to the server blade directly. In the portal. But in both cases, you need to be on the server blade, click the firewall option, and it brings up your firewall settings. And you'll notice there's two aspects of the firewall settings that are shown on the screen on the right here. One is the allow access to Azure services. This allows your Azure-built web apps and so on to connect, because they don't connect via an IP address. But if you're on-premise, your management studio, your various on-premise applications, they need to have a firewall rule to let them get through. And the screen here is actually showing a completed firewall rule. When you first connect, it'll actually say, you are at this address. Do you want me to add a firewall rule here? And one final point, if you happen to be an administrator in the portal and you open up Management Studio and try to connect, it will actually prompt you, if you don't have a firewall rule, again, only with the newest tools.
Right, I've noticed that. It's cool.
It will actually prompt you and let you create a firewall rule. Again, not every user. You have to be have access to the subscription.
Right.
But as an administrator, you should think about doing it through the portal. But you can also do it with Management Studio if you have permissions.
Yeah, I remember being surprised the first time I saw that. Had SSMS open and I went to connect, and it popped up and said, "You don't have the firewall open. Would you like me to open it?" Yep. Click the button, and I got to log into my Azure account, do the two-factor commit and all of that. Commit? I didn't mean to say that. That must be a DBA. Two-factor authentication, and went ahead and created it and word and grind, and we're done. Yep. So pretty cool. All right. So we're through the firewall.
Yep.
Now what?
Now you've got to be authenticated.
Sure.
This is, with a few variations, which I'll point out briefly, this is exactly the same as on-premise, is you either use SQL authentication or you use Active Directory, either via Windows Auth or Active Directory Auth if you're in SQL database. And you can choose the scenario, but your user has to have a login or a user account in the database, and I specifically a login or a user account. Again, this is the same as on-premise or in VM or in Azure DB. The whole contained user scenario. It's just you really want to use contained users in SQL database particularly.
And that's for that portability scenario.
For the portability scenario. So you basically get authenticated, and then you get permissions. The big difference with SQL database is your users can either have a login in the master database and user accounts in the user databases. But from an administrative point of view, you have the original user that is essentially a SQL authenticated user. And if you have Active Directory configured either Azure AD or integration with on-premise with SQL DB, you get one. You
get an additional administrator, right?
You get an Active Directory administrator. Right. That can be a group or a user.
It can be a group. Okay.
But what you're not going to do is start creating additional SA type accounts in SA. That does not exist. You can create a user that can create new databases, and you can create a user that can create new logins. But that's to the extent that exists in the server level. That's all that exists.
Right. Yeah, I did notice the server level roles were a bit different.
They're different, and we explain those in detail in the book, and the walkthrough goes through exactly setting these up. At the database level, they're exactly the same. You can give people permissions as DB owner, and so the various roles you have at the database level are exactly the same.
Right. So we're not going to wind up talking about creating users, creating roles, creating permissions, and all that, schemas and all that, because it's the same. We don't need to take time here, right?
Correct.
All right. So let's move on. We've talked a little bit about security. Let's move into what you called in the book's title, or sorry, the chapter's title, data resiliency. To me, that's backup and restore. as well as some geo-replication scenarios.
It's backup and restore and geo-replication. Again, I use the term data resiliency because you have various scenarios where you need this resiliency. You've got user error you got to recover from. You have various corruption issues that you may have been used to dealing with in an on-premise. You actually don't have those in the cloud, but you may have archiving capabilities you need to do. You need to move stuff to multiple regions. You need your resiliency available for users to access your data in all kinds of contingencies.
Sure. So to me, coming from an on-prem DBA's view, two things you mentioned right up front are really significant. There's recovering from user error. So how do I do a point-in-time recovery, for example? Or there's the server went down, or the data center is flooded, and we've got scenarios to address each of these, right?
Yes.
Okay. So let's talk about these broken out by whether we're in a VM or whether we're using Azure SQL Database. Let's start with a VM. What are my options, and what's new and different?
Well, the first option is understand it is not different in a VM. You have attached storage as your default in a VM, so you're going to have your various drive letters, and
so back up to my E drive.
Just back up to your E drive or whatever drive you want to have, and you're done if that's as far as you want to go. You can have Azure actually do this backup for you, so you didn't have to think about it. It backs up whatever schedule that you have set up, and it's moving away from infrastructure as a service closer to a platform as a service. But you're still in infrastructure. But you're saying, Microsoft, can you just handle the backups for me? And it backs it up to whatever location you specify.
So I noticed that option when I used the portal and created from a template.
Yes.
But if I'm going to upload my own VM, is that option available to me?
You can also do that exactly the same. You also have the choice to back up to a URL. Again, this is also available on-prem to back up to URL, and you actually may want to use this as part of a migration scenario, which we do talk about elsewhere in the book. But you have much larger capabilities when you back up to a URL. Is you're not limited by the size of your attached drives.
Sure.
And you may have attached drives may all be premium, and you want to back up to standard storage.
So I can get some cost savings there. Okay.
Save money.
Right.
And there's a new option available in a VM called file snapshot backups. And this is an option that's available if you instead of using attached storage, you use blobs to store your MDF and LDF and NDF files. This is particularly used for very, very large databases. You're going to use blobs for your storage. And a snapshot backup is using Azure Snapshot backup capabilities to essentially, on a schedule, using the same commands you're familiar with, backup database, backup transaction log. That backup command just creates a snapshot. So it's essentially instantaneous backup of, and this is key, it backs up all your data files and your log files every time you do a backup. So each transaction log backup is actually a backup of the full database and the transaction log, and you can do very quick point-in-time restores to any point in time. This is really designed for very large databases for when your data files are stored in blobs. For that scenario, this is a great solution.
So I know that there are going to be experienced DBAs out there who hear about this file snapshot option and think, sounds cool, how can I validate the backup? So do I have access to those snapshots to be able to restore them somewhere and test them?
Yeah, so these are snapshots you can restore to another machine in the cloud and then validate them. This is particularly used, one scenario it's used for is if I have I have a business case where I have these large backups and I want to do some business analysis on it for what happened in this month or this time period. I can actually restore it to a point in time on another machine, could be a lower powered machine, that I can restore it and do my data analysis independent of my transactional system that I don't want to overload.
Oh, so I mean, even though it's a new technology and it's using this cool new Azure Snapshot feature, it's just a backup. I mean, as far as SQL Server is concerned,
the backup commands and restore commands are essentially identical except for the words with file snapshot.
Okay.
And that's only during backup. During restore, you just point it to the backup. Restore doesn't even really know. That's
a cool thing.
You need the newest tools.
That's a cool thing. Right. Sure. Okay. Well, let's compare that to what happens in Azure SQL Database. Now, as I mentioned, I've created a separate course for MVA on data recovery with Azure SQL Database, and we talk about backup and we talk about restore. I found I couldn't talk too much about backup. There wasn't a whole lot to do, unlike on-prem or in a VM.
Yeah, so at all service tiers, what you get automatically out of the box is you get automatic backups. SQL Server takes a full backup as soon as you create it.
Yep.
It does a regular full backup, but in between it does differential and transaction log backups. Essentially, so at any given time, your backup is within 5 minutes of your current time. Right. And those backups are locally redundant, and most importantly, they're geo-redundant. So
where do they go? Where are the backups stored?
They're stored in blob storage.
In my account?
They're stored in your account in blob storage in multiple blobs. So if you have any disk corruption, you've got it stored in multiple places. Right. Disks always have corruption.
Sure.
Things fail. So it's stored in multiple locations locally, and it's stored in a geo-redundant fashion. Okay. So either if your local data center is down for some reason, or if for some reason you just want to create a copy of the database in some remote region, they're available at any point in time. Sure. And you can do point-in-time restore, or you can do restore to the most recent time. Right.
So
the length of time.
There we go.
Yeah. The length of time that these backups are retained are dependent upon which tier you're in. Basically, as of today, and these limits change over time. Sure. Is if you're in basic, they're stored for 7 days, and if you're in standard, you get a large amount of time. I believe it's 15 off the top of my head, and it's 35 if you're in premium. Right. And this is the length of time that it's retained. If you want to keep your data for a longer period of time, you need to archive it. And the current archiving technology is to create a backpack file. And the thing to be aware of when you create a backpack file is if you have active transactions occurring, you want to create a backpack from a copy that is transactionally consistent, or you want to create an archive while you're not having transactions occurring. Sure. Because it's a sequential creating the backup, so you can get inconsistencies if your database is active, or you use the backups you already have to create a copy and backup from that copy.
You read my mind on that, because I was wondering if we could create the archive from existing backups rather than touching the live system.
Yes.
Okay.
The key point about this is if you've got hundreds and hundreds of databases, don't do the archive of all of them all at the same time. Right. You will have performance issues.
Sure. So you've addressed a common question I've heard, which is, how do archive? What do I do after the 30 days is over? The other thing I want to make sure that we mention is a gotcha that I ran into while setting up some demos for a course. If I delete a server, that deletes the databases, but it also deletes all the backups of those databases that were on that server.
Yes. So first of all, if you delete a database during the time period that you have retention for your server, that database, it can still be recovered. Right. So if you've got 7 days or 15 days or 35 days, you can recover the database. But yes, if you delete the server, everything about that server goes away.
So do be careful.
Yes.
Do be careful.
Again, there's virtually, I hate the word virtually. There's very little reason in many cases to delete a server, because it really is just a logical container that has almost nothing in it except for your administrative access, the server load firewall rules. And so there's really very little reason to delete a server. Well, so it takes up no resource. It doesn't cost you anything.
That was my question. Yeah, let's drill into that. I mean, if I'm a development shop and I want to be able to create lots of test and dev databases, I'm going to want to get rid of them when I'm done to save cost. But if I can leave the server up, it's certainly more convenient the next time I want to be able to create a database. It's nice to hear that it doesn't cost anything.
Almost no storage space associated with the server.
Sure. Okay. All right. So that's the backup piece.
Yes.
What about restores? To me, again, coming from decades really with SQL Server, where you really have to plan out your restore sequences carefully, it's a whole other story here.
You basically restore is in the portal. It's incredibly simple. You just basically go, I want to do a restore of my database, and it basically there's a couple depending if you're going to do it to a point in time or most recent. The place you go in the UI is slightly different. Sure. I can create a copy of a database, which it uses the same backups to create a copy. And when I create that copy, I can pick the restore point, or I can use a point-in-time restore and say, I want to restore to as of midnight last night or as of 5 minutes ago. Sure. And it's all handled in the portal, or again, you can do it with PowerShell or REST API.
So we'll see what that looks like in the demo coming up in a minute. But one thing to point out is where the restore goes by default and what it's called, and that's different than on-prem SQL Server.
When you do a restore in Azure SQL Database, you do not restore over top of your database. Right. When you restore, you create a new database. So for a short or as long a period of time as you want, you actually have two databases The new database has a different name than the existing database. And then you need to either essentially point the users to that, or you can do the whole rename.
Drop and rename, right. So it's important to point this out because there may be an impact on your storage quota for your particular service tier.
Yep.
And then ongoing costs for storage. So be aware you can accumulate multiple copies.
And you can delete first and then restore, because deleting does not delete as long as you don't delete the server.
Don't delete the server, right?
You can delete the database and then restore the database and save your user costs.
Well, let's see what this stuff looks like. Let's take a look at a demo.
Sounds good. Let's go.
In this demonstration, we'll take a look at creating security accounts in an Azure SQL database. I'm starting in the portal, and I'm looking at the settings for the MVA migrating SQL database that I created earlier in this course. You may recall that at the time I created it, I created a single user that was the admin for the logical server and then had permissions within the database itself. And we're going to explore adding additional users at the logical server level as well as within the database level. So though I'm starting here in SQL databases and I'm looking at MVA migrating SQL, what I really want to do is I want to go over and look at the server itself. So this is my MVA migrating SQL logical server. I'll go ahead and bring up its properties. And this is where we'll see, among other things, that my database of the same name is sitting here and is online. And we'll see that I've configured myself as a server admin. And that's how I'm able to connect with Management Studio. So I've got a couple of query windows open, ready to try some stuff out. And I'm currently connected to this in SQL Server Management Studio, connected from my local desktop up to Azure SQL Database in the cloud. And there's my logical server name, MVA migrating SQL.database.windows.net. And we can see I've got a user database with the same name. Hopefully that doesn't cause any confusion. And if you're used to SQL Server, you're used to being able to take a look, for example, at the server level security. And this is where we'll see logins, for example. And you're used to being able to go down into the user database and look at security there and see things like users and roles and so forth. And we're going to explore this just a little bit. But I want to start at the server level. And what I want to do is I want to add an additional login at that logical server level that will be essentially a peer, a sibling, if you will, login of the CF Randall account that I created when I first provisioned the logical server and its database. So from this connection, we'll see I've got a typical T-SQL statement, create login, login1 with a password. And we'll see that I'm connected to the master database on this logical Azure server. I'll go ahead and execute this. And I would expect that that is completed successfully. And if I refresh my container, I will see that new login1. So what happens if I go over to this other connection window? This other connection window. And I go to change my connection. And I'm going to try and log in as that login1. And I am going to put in a password. And we'll see that the login failed. All right? Because even though I've created a login at the logical server level, I'm not allowed to connect to the master database. Let's cancel out of here and go back to my script. And what I'll need to do is I'll need to create a user in the master database to allow that connection. And this is a little different than what you might be used to in traditional on-premise SQL Server. So in this window, I'm still connected as the server admin, and I will go ahead and create a user from that login, create user login one user from login1. And then we'll go ahead and, just to save myself some typing, I'm going to copy this password. We'll switch back over to this other window, and we will attempt to connect as that login1 user. And I'll just paste in the password here. And we'll see that it is connecting. All right, so if I look at my status bar, I've connected to my MVA migrating SQL database.windows.net, and I'm connected to the master database, and I can do whatever a minimally privileged user could do in master. I don't have any specific privileges here. I've just got a user account. All right, now, what happens if I want that user to be able to switch to one of the other databases? Right, if you recall, I've got a database called MVA Migrating SQL. Now, you may have learned earlier that you can't use the use statement in this mode in Azure SQL Database, but we can use the pull down here in SQL Server Management Studio. And if I try to change over to MVA Migrating SQL, see what happens. SMS is whirring and grinding and making me wait. I would expect failure here in a moment. Because if you recall, this is a brand new login, and while I created a user account in master, I haven't created any other user accounts. There we go. And I get a pretty detailed message. The server principal login 1 is not able to access the database MVA Migrating SQL under the current security context. All right, so what can I do about that? I can switch back over to my list of scripts, and what I can do is, as CF Randall, who's the server admin, I can switch to the user database, and then I can create a user in that user database, create user login user from the server login login 1. And if you've done traditional SQL Server, this should be very familiar to you. I will go ahead and execute that. I will switch back over to my user. I will change my connection. And instead of just trying to log in, which will connect me to master by default, and then switching, I'm going to go to options here, and I'm going to say I want to connect right to my MVA Migrating SQL. Oops. Okay, so this, because it's a minimally qualified user, I can't even use that ability. I'll have to switch later. So that's fine. Let's connect to master. All right, so I'm connected to master. Now let's switch over to MVA Migrating SQL, and I'm good to go. All right, so down in my status bar, I'm connected as login 1, and I'm connected to the database MVA Migrating SQL. All right, well, back to my scripts. Let's take a look at another thing we talked about in the presentation, which is the idea of a contained user, which is something we've had in the most recent several versions of SQL Server, and is also supported in Azure SQL Database. So to create a contained user, I'll want to be pointed to my user database, which I am, and I'll create a user with a password. So instead of being associated with a login, I'll just be directly associated with the user account. So I'll go ahead and run this. And now we'll see if this works. Let's open up a new session here. Let's go ahead and right-click and change my connection. And I'll want to connect as user 1. And I'll want to log in. And let's see if I can connect. Now, by default, what's it trying to connect to? It failed. Why did it fail? Because I was trying to connect to master by default, if we look in the options. But if I try to connect to MVA Migrating SQL, let's see how that does. And sure enough, there I'm in. So again, looking at my status bar, I'm connected as user 1 to my user database. Again, no special privileges yet, just created as an account. But I've essentially bypassed logging into the logical server and connecting to master by going right to the database. And the handy thing, as you heard in the presentation about this, is that a contained user makes it easier for me to migrate this database to different servers without having to recreate and synchronize the logins. All right, let's try something else now. I'm going to go back to my master database here as my admin account. Let's just... And I'm going to create a second login with a password. And as we would expect, if I try to connect as that and then create additional logins, even though I'm in master, it's going to fail. Let's test this out. I am going to just start a new query window, and I am going to connect. Make sure it's pointing at master and connect. So I'm going to go back to my script, and what I'm going to do is I'm going to try to have this login 2 account created instead by our login 1. And just to be clear, let's make this login 3. So I'm connected as login 1, as I can see at the bottom, and that login doesn't have any special permissions other than the ability to connect. So I'm going to see if this is able to connect, to create another login. Let's execute this. I expect a quick failure, and I got it. The user does not have permission to perform this action. That's fine. That's what I would hope. The only administrative account is that CF Randall account. So if this were in an on-premise instance of SQL Server 2016 or earlier versions, what you would do is you would either grant specific permissions to login 1 or you would move login 1 into server roles. And we have a very similar approach that we can do in Azure SQL Database. So again, I'm connected as myself. And what I'll do is I'll add that login 1 user, not the login, but the user associated with it, to the DB manager role. And I'll add login 1 user to the login manager. Let's see what that does for me. Looks fine there. Let's go back over and see if we can create a login now. That's better. And so if I refresh, I should see login 3. So at the logical server level connected to master, we're seeing that we're treating it much like we would treat master and logins at the on-premise level, except the names of our roles have changed slightly. Now, the same kind of thing happens at the database level as well. What I'm going to do now is, again, connected as our login 2 user, I'm going to attempt to switch over to MVA Migrating SQL. All right, well, it completed successfully. So we are switched over to my MVA Migrating SQL, and what I want to do next is I want to see about creating a, let's make this login 3 user because login 2 had some problems earlier. I'm now in my user database. I'm in MVA Migrating SQL as login 1. I want to see if I can create a user in that database. And we would expect that to fail. Because if we follow that sort of logical progression, I first created, way back here, I created that login 1 account in master and created a user to correspond to it. I switched to my user database, which was MVA Migrating SQL, and I just created a user, but I haven't yet granted that user any permissions. So back in my other connection now, where I am the sysadmin, I'm that privileged account, I'm going to allow the login 1 user to join the DB owner role in the user database, and that's what you're accustomed to, I'm sure, in on-prem SQL Server. We'll go ahead and execute that. Whoop, hang on. Let's see. Oh, I'm in master. I see what the problem is. Right, I can't do that in master. I need to do what my comments told me to do, and I need to switch to that user database. And now we'll give it a try, now that I've read my own instructions. There we go. And to test this then, we will, I'm going to take some code over here. We're going to switch over to my login 1 user, and the first thing we'll do is the command that failed before, we will create a new user in this database. That succeeded. Let's go double check that that's there. So there's my login 1 user that I'm logged in as. Here's my login 3 user that I just created. All right, I'm not going to bother with my login 2 user. I'm going to cut right to seeing if this user, login 1, can create a contained database user. Create user 2 with password. And the answer is yes. Why? Well, because we dropped that login 1 user into DB owner, and they can do whatever they want now inside that database. So what I hope you've seen in this demonstration is that the approach to managing Azure SQL Database security is very much similar to what you did on-prem. There are a couple of different tweaks, such as the inability to use our use command, the separation between logical server level logins and users in master from database users, and especially contained database users.